So we are on page 4, just recapping the video from yesterday and so forth. So we're talking about polynomials this chapter, which means we're going to have a lot more stuff included in them now, not just your x squared plus 2x plus 4. So we talked about what it means to be in standard form, the degree, and so forth, and then the different types. So what did we call it, just to refresh my memory and yours, what did we call it if the highest degree was 0, meaning there wasn't an x variable in it? Good, that was a constant. How about if the highest degree is 1? Good. The highest degree is 2? I'm glad that that was the loudest because we just got done spending a month on quadratic. How about 3? 4? And how about anything higher than that? It's just the number degree. So if it was the highest exponent was 10, it would be degree of 10, 10th degree, you would just call it. Okay? So let's take a look then. And we talked about evaluating. You had to do that in your warm-up and so forth. But now, let's skip to page 5, looking at example 7. Now we're going to take these polynomials, some which we have seen already and worked with, and graph them. Okay? So, remember. I just want to remember. There we go. F of x is the same as y. Kind of got to get in that mindset as we're going through these, okay? Because starting now, you'll see a lot more of f of x instead of y equals, even though we have spent years and years and years hammering in your heads, y equals, y equals, y equals. So if I'm going to graph number 7, yes, it's the function f of x equals 2, but in the back of your mind, you can also be saying that's the exact same thing as y equals 2. So what would that graph look like? Horizontal. Okay. And here, because if you think about it, it's in the form y equals mx plus b, so 2 would be my y-intercept. And from there then, the only way that I can have this other than being on an axis would be a horizontal line. So there is my function, my graph. What degree is it? Huh? It is, yes. So the degree is the number, so that would be the highest exponent would be 0, therefore making the type of the function a constant. And then when I say number of zeros, remember those are your solutions, those are your x-intercepts, those are your roots. All of those mean the same thing. So how many zeros do I have for this function? How many times does it cross the x-axis? There you go. So we have 0 zeros for that function. Okay, let's take a look at number 8. Remember, this is the same as y equals x plus 1. We've hammered this into your brain. How would I graph that one? Oh, come on. I should be hearing more because we've hammered it so much into your brain. Thank you. Phew. I was starting to think that you weren't paying attention. So yes, your y-intercept is that number by itself, and then your slope is 1 in this example. So you would rise 1, run 1, rise 1, run 1. Or you could go down 1, left 1. Because a negative divided by a negative is also a positive. So what is the degree of that function or polynomial? That's a 1, because remember, we do have that imaginary 1 on basically anything as an exponent. It's even on the whole number 1 there, too. We just don't write 1 as exponents, because it's a waste of our time. Type of function is good. And how many zeros are there? Perfect. Now, let's take a look at number 9. Before we get our graphing calculators out, hopefully you remembered those, talk to me about what the degree is of this function. If I have f of x equals x squared plus 2x minus 3, the degree is 2, which makes it what? Quadratic. We just spent all last chapter graphing these. So graph it. Good review from last week assessment. Go ahead and graph that quadratic equation, y equals, or f of x equals x squared plus 2x minus 3. Most of you are finishing up that example. What did we get for our vertex? -1, -4. And then use your steps, right and left 1, up 1, right and left 2, up 4, right and left 3, up 9, okay? You should have that parabola fully graphed. Now, let's get our graphing calculators out and just make sure we're right and make sure we know how to use our graphing calculators because it's been since chapter 2, okay? So the equation is f of x equals x squared plus 2x minus 3. Let me get my calculator here. We don't even know what the app is called. It's the graphing calc. This one right here. The one with the squiggly, graph and calc 83. It's Mr. Fontaine. He took my iPad and took a picture of himself. So now I'm leaving it on there so everyone gets to see his ugly face every time I go on. You can tell him I said that. That's fine. Yep. You can tell him. We kid around with each other. It should be, yep. Huh? It is. So look for it because you usually have to scroll down quite a bit. Don't do the search. Just go to all and then scroll down. Okay? So first things first, you need to enter the equation into your graphing calculator. How do you do that again?
Wait, y?
Yes, y equals. Okay? Now don't pay attention to the rest of mine. I'm just getting prepared for later. The equation was x squared. Okay, because remember it's the same thing as y, f of x. Y equals x squared. You do have to use the caret button, remember, right underneath clear in order to enter exponents. And then what was it? Plus 2x and then minus 3? Was that the equation? Look at your notes. Thank you, Matt. Okay. Now, we've entered the equation to tell our calculator what to graph. How do we see the graph? You press graph. There you go. I'll be right there, Olivia. Now, if you ever go into your graphing calculator and you get something like this, where you only see a green line, reset your zoom, your window. And how you do that is in the bottom left-hand corner down here, you click zoom, and it's zoom standard. That goes back by the origin so that you see the full shape, and then you can even zoom in farther and whatnot. So let's just double check to make sure our points were right. We got a point at -1, -4, right? That was our vertex? Perfect. And then our next point and so forth, and you can just keep double checking and making sure, especially the y-intercept, x-intercept, sorry, which we got as 1, 0, and then you should have gotten it -3, 0. Okay, so as I'm coming around talking to and making sure everybody understands, if you have a question virtually, please ask, otherwise put it in the chat and somebody here will let me know what the question is. And then try the next equation. Try graphing number 10, x cubed minus 5x plus 2, because you haven't done anything like this before. Okay, so as some of you are asking, is it right? This is what your graph should look like. And as you are transferring it from the graphing calculator to your note sheet, you got to think of some of those key points. I don't want to make all of these points to get that exact curve. So what are some key points that I would want to transfer over to my graph? The y-intercept, the x-intercepts, and then I would even say like those two peaks, like the maximum and the minimum. Okay, so the y-intercept was at 0, 2, right? The x-intercepts, about, yep, totally fine. And this is all going to be approximate. You don't get to use your calculator on this chapter. We're just doing it right now so we can graph and try to find patterns that will be able to lead us up to graphing without the calculator. Okay? So we have those two. The peak, was it at like negative 2.3 and 6.3? Or what was the maximum? Negative 1.3. Okay, I was wrong. I was thinking of the y-intercept, x-intercept. Okay, so negative 1.3 and 6.3. 6, so right about here. And then the minimum was negative 2.3. Hold on, let me see. Negative 1.3. There we go. So like that. Okay, so we go up. Oopsies. I need my marker. We go up to our maximum, down to the minimum, then it crosses the x-axis and keeps going. Obviously, mine doesn't look as good as the calculators, but that's because it has a lot more technology. So, taking a look. Degree is what? Makes it what type? How many zeros were there? And how many were there for number 9? Okay. Go ahead and try number 11. Same way. Try number 11 the same way. Graph it. Okay, so let's take a look here. Y to the 4th. Let me go to my calculator. It's y to the 4th. Or x to the 4th. Here it is. Okay, so delete. Okay, so there's my equation, right? X to the 4th minus 3x squared minus 2x squared, or minus 3x cubed minus 2x squared plus 7x plus 1. Okay, so if I go to graph, I forgot to take the other one off. 1 second. Now go to graph. There you go. So it's just a matter of picking those key points and approximating them. Okay, your x-intercept is about negative 1.5. Your minimum down here is approximately at negative 0.9 and negative 4.1 almost, and so forth. So making sure that you take this and you transfer it to your graph on your notes. Okay, so what's the degree? Which makes it a, and how many zeros were there? 4. Okay, now we have 7 minutes. So, right, we get out of here at 11:03? Oh, we have 7 minutes. What I want you to do right now, looking back at these graphs that we just graphed, 7, 8, 9, 10, and 11, I want you to, with somebody, let's say your 1 o'clock neighbor, or your 1 o'clock partner, buddy. I want you to answer these 2 questions. Look for similarities and differences. Okay, for the first one, you're looking back at these examples. Do you notice a pattern? with even degrees, odd degree polynomials, and so forth, and the degree number and its root, and then also what happens if your leading coefficient is negative. Try to come up with some things that you notice with your 1 o'clock buddy, okay? Go. Huh? Go. Okay, so. You want to help? Thank you.
So if your degree is all
Yeah.